Okay, welcome back, and we're going to start off our discussion of igneous rocks and igneous features by talking about where do the igneous rocks come from, and that is going to be a magma. So that's going to be this molten material that is inside the earth, and then when it comes up to the surface, it's going to be lava. So what is magma composed of? So it's going to have a liquid component that is going to be composed of various kinds of ions. So if you take a look at those ions, you notice that you've got aluminum and calcium and sodium and potassium. Do those sound familiar? Well, they should, because when we talked about the silicate minerals in a previous lesson, we said that the fundamental building block of the silicate mineral was the silica tetrahedron, which was a silicon, and then it had the 4 oxygens sticking off of it. And we said that it had a net negative charge, which meant that if you had a silica tetrahedron here and a silica tetrahedron here, they're not going to want to get near each other because they each have a negative charge, and like charges repel. So what we needed was something to go in between those things to help hold them together that was positive in charge. And that's what these things are. So the aluminum and the calcium and the sodium, potassium, iron, and magnesium, those are all ions that help to hold these silica tetrahedrons together to make the silica minerals. Okay, then you also have a solid part to the magma. Now the solid part could be actual silicate minerals, because some of the silicate minerals, such as olivine, can withstand very, very high temperatures. But then you have other silicate minerals like quartz, which don't. So under high temperatures, they tend to melt. So in this solid part of the magma, you're going to have some intact minerals, and then you're also going to have like some chains of silica tetrahedrons, clumps of silica tetrahedrons, isolated silica tetrahedrons, and so forth. Okay, then you're going to have some gases in there. So you're going to have water gas, and then carbon dioxide, and then sulfur dioxide, and hydrogen, and nitrogen, and other gases. So there's a multitude of different kinds of gases that you find in magma, and then when these gases come out, that's the reason why you detect particular odors that are coming from a volcano. Okay, another thing that your textbook mentions is the difference between a wet melt and a dry melt. And they said that a wet melt contains more volatiles. So a volatile is going to be something that easily turns into a gas. So for example, water. So water under surface pressures and temperatures is normally a liquid, but if you raise the temperature enough, it becomes a gas. So water is considered to be a volatile. And this is going to be very important because water is going to help rocks to melt easier. Okay, and then E, the types of magma depend on the amount of silica that they contain. So that your felsic kinds of rocks, so an example of a felsic rock would be granite, is going to have the most amount of silica in it. On the other hand, you have the ultramafic rocks, like periodotite, that is going to have the least amount of silica in it. All right, let's take a break, and when we come back, we're going to talk about how does magma form.